Fireshark by Stephan. Give him a warm applause. Thank you very much.
All right, thank you. Can everybody hear me all right? Yep. So thanks to Dale for taking my spot. Had a few complications last night. Went out with my friend Barnaby Jack, Josh, and Jack Daniels, and stayed out till about 7 a.m. So I don't know. Jack, I think Barnes is still missing. So if anybody sees him, let me know. So today I'm going to talk about a tool that I wrote and open sourced called Fireshark. The presentation format is going to be about discussing this tool, but about discussing in general the malicious webscape. And I'm going to explain how to use this tool, how it's helped me in really analyzing malicious websites. But just not a single malicious website, mass compromises, hundreds of thousands of sites at a time. I'm going to give you an introduction into Fireshark, and we're going to go through, depending on time, 1 to 2 examples of real mass injections. So let's start at the beginning. What is Fireshark, for those of you who haven't heard of it before? It's a tool that I wrote alongside Vladimir Pallant, who you might have heard of from using his AdBlock Plus Firefox plugin. He's one of the kind of the main guys in all the extension forums for Firefox plugins. The main goal of this particular plugin, this tool, this project, was to organize and analyze malicious website data. To take that data and to correlate it into similar attacks. So I'm a researcher at WebSense Security Labs, and I deal with exploitation, anti-exploitation, malware, and sometimes I have to deal with so much data, and I really want all the steps. I want all the pieces of the puzzle. So I want to know if I'm dealing with the same attack when I'm looking at hundreds of thousands of sites that look like they have the same pattern. So what this helped me do is figure that out. If I can figure out there's a similar mass injection attack, all these sites, they got injected with something that looks like similar code, I can see if the same compromise, they're going to the same redirectors, and they're ending up at the same exploit sites. And I can look at the patterns of the content. We're not just talking about signatures here. We're talking about particular hosting providers they're on, IP addresses, ASNs. We are looking at the content in terms of the kits that they're using too. And again, it's not going to be signature-based. It's really about the format of the page, using certain kind of clustering technology within the content. So the current status of the Fireshark project is that it was released April 2010 after Black Hat Europe. It's GPL'd, and the next version, which I'm working on, after getting about 10,000 downloads of Fireshark version 1.0, is going to be released either at the end of this month or at the beginning of next month. And it's got a lot more features to it, given all the feedback that I had. So the architecture of it, again, it's a browser plugin. It's really used to automate and completely remote control Firefox, and eventually it's going to be used for Internet Explorer as well. You start it, you give it some data, and then it passively logs the information to a particular proprietary log format. It logs the connections, and we're talking about when we say connections, it's the contextual reference. So it's different than just throwing a scanner like Ethereal Wireshark onto your machine, because that's going to see the connections from your machine to somewhere else. If you go to a web page and it's got a page within that page and another page within that page, and they're all making links, it's going to make the connections within the pages, not just the machines. And this is very interesting information, especially if you've been injected with an iframe. You see the page, you see that it connects to that page, and you see all that information. The source, that's pretty easy. But more interestingly, the DOM. So in majority of cases, these compromised pages are using obfuscation. And as we'll see, obfuscation tools that are out there, they're really not sufficient. So this dumps the JavaScript function calls as well as the finalized DOM. So you don't have to worry about what is that page doing. I got to run another tool and another tool to figure out what's the actual exploits that are being used. This will show you. It also shows you the page lengths, so you can do link analysis, and then the screenshots. There's a lot more functionality, but that's kind of at a high level majority of things that that you'll be given. And then your job, given the end result of a result like the log file format, is to take it, and you've been given via the Fireshark project post-processing scripts, and you can create graphs, information. You can put it into a database and correlate that data. So to understand how this tool is useful, we're just going to quickly go through what the webscape, in terms of the maliciousness of it, looks like right now. So from 2009 to about this year, we've seen about a 225% increase in the number of new compromised legitimate websites. These are sites, I think I have a few examples here that you might have actually gone to, but within the last year, they've been compromised. Your machine might have been patched, it might not have been patched, but you've been redirected to code that has potentially attempted to execute on your machine. So the translation is that there's a very large chance that there's been an attempt on your machine for exploitation. So you might have heard of some of these stories, you might not have. The Drudge Report, Horoscope.com, Slacker, eWeek, New York Times, even Yahoo Mail, Expedia, all of these were at one point compromised. Sometimes not directly through their content, but when you went to that web page, you were fed content through an affiliate ad network. And these are all victims of malvertisements. Happens all the time. It's still pretty easy, although it's being worked on, to infiltrate a lot of these ad affiliate networks, get a Flash exploit or JavaScript code actually sent through and fed to the user. Some of the mass compromises that happened this past year, Gumblar was one of the largest, 70,000 compromised websites. A smaller one was one we coined called 9Ball. It had about 40,000 compromised websites that it actually went out and injected code into. And the typical process is that it'll inject code, the site has now been infected. When the user goes there, they're actually sent through possibly 1 to 10 redirector sites. And these redirectors are doing different things. They're logging your IP address, they're checking blacklist, and if you are on a blacklist, like a lot of the security companies are, a lot of the academic universities studying these types of sites, you'll just get redirected to, in this particular case, ask.com, for example, instead of the malicious landing page. So when I'm looking at a mass injection like this, I want all the pieces to come together for me to say, yes, this is the exact same attack. I mean, 40,000 compromised websites is quite a lot. I have to verify and make sure that it is the same exact attack. So generally, a compromised website is injected with an iframe or a script code. This is actually something that Fireshark produces, which is a display of when I went to a particular site, what happens. Went to the website, it made a connection to several other sites. It could be a mashup site using several different functionality within other sites. But there's an iframe connection, as we can see on the top left, to under response, iframe connection out to a malicious website. Now, it might be an iframe, or the code itself might actually just redirect the users automatically using a redirector and then to the exploit site. And in many cases, what I'm more interested in is not that it's compromised. I'm pretty sure that it is, but I want to see how big a deal it is. How many sites have been compromised? Are they going to the same exploit site? So here's another graph that we'll see that Fireshark produces, which quickly gives me a very visual perspective if I should pursue this further. What we're looking at is the exploit site in the middle of the screen, and all the compromised websites, how many of them are there that actually go to that exploit site. Once at the exploit site, there's generally a lot of JavaScript that's run. Obviously, the JavaScript's run on the client-side machine. Checks are done, what versions of certain plugins, third-party add-ons are you using. If it determines that there's no exploitation possible, generally the user will be served fake AV or rogue antivirus. It's one of the most popular methods out there right now. This is a screenshot if you've actually you've most likely seen it, but if you've never seen it, you just get something prompted to install it. Once you install it, users are generally tricked into actually paying for this rogue antivirus. And there's several variations. It's actually most of the time customized to your operating systems. If you're running Vista, it's going to have a more Vista look, XP, more XP look. This is actually the same exact program. It just looks exactly how you want it to look for your particular operating system. But the more interesting thing, at least for my research, is researching exploit kits. There are dozens of exploit kits out there. They're generally sold for about $100 to thousands of dollars, and they're actually really hard to attain. Sometimes you can go onto a web page. Generally they're Russian websites, and you can't just pay with a credit card. You have to use web money, and generally you have to be in the group. They have to have known you. This background check is quite extensive. Crime Pack, Eleanor, Phoenix, these are all large web kits that are sold and compromised of some of the latest and greatest exploits out there. Anywhere from CVs that are ranged in 2003 to some of the latest PDF exploits in 2010. They're constantly updated and they're sold like commercial software is sold. They're targeting Firefox, Internet Explorer, Opera, Java Reader, Java Acrobat Reader, Flash, and other third-party add-ons. But these are the majority that will get updated to be targeted. They're also using obfuscation. So if you've never analyzed a web page that has been compromised, and majority of developers who are looking at these pages, they'll actually pass this by if they're actually reviewing their source code on a common basis quite often. But this is what it looks like. You can't make much of it. It has to be run to be interpreted and determine what it's actually doing. And it's generally polymorphic. That means that every single time a user comes to this page, they'll be served different JavaScript, different obfuscation. So antivirus engines that are simply relying on signatures are having a very hard time with this. So let's look at one, for example, Crime Pack. This was released, at least version 2.8, March 2010. Adobe Acrobat Reader exploits, Java runtime, an old one like MDAC, targeting heavily on the IE side. Attackers have their own systems in place so that they're monitoring if a lot of these PDF exploits, JPEG exploits, Java runtime, jar files, anything are getting detected. They're being updated. They're working on their polymorphic nature. Same thing goes with that as it did with obfuscation. Those PDF files, they're not static PDF files that you're getting and you can just hash. Majority of the really good kits out there, they're polymorphic. They're changing every single time that the user goes to that site. It's a different PDF file. Again, they share amongst themselves, most of the attacker groups blacklist, so that, for example, JS Unpack, Wepawet, these sites are generally blocked through a blacklist that's shared amongst the underground. So there's a lot more, obviously, anti-emulation, cryptor kits. There's a lot of work that goes into this. There's a lot of money involved, as we saw in some of the talks yesterday, and so that they can pay for decent developers to work on these kits. So that was the quick overview of what I have to deal with, what groups that I work with, and groups like my group work on. So when we're working on this, we're looking at attacks, obfuscation, redirector, several sites all over the place. It's pretty messy. So what we had is a need to organize, analyze malicious website data. Get all the kits together, all the content, all the sites, all the IP addresses that are connected to, figure out if it's the same attack. Collect the kits, collect the exploits, analyze them for generic detection in most cases. And at least from free resources, not in-house resources, there wasn't out there what I needed. Great tools that are out there. Mozilla uses it on a constant basis. Rhino Debugger, some of the more proof of concepts, some like the SpiderMonkey code that helps you with JavaScript obfuscation. JS Unpacked. These are great sites, but majority of these sites and these tools help on one website, not hundreds of thousands, that I can just feed it and get a lot of information back. So they weren't sufficient. But in many cases, for me at least, they weren't working on some of the latest kits. Phoenix Exploit Kit, it couldn't interpret the script code. Same thing with JS Unpack. It constantly just had problems that it couldn't fully decode the content on that web page. You know, majority of the cases is because these are JavaScript emulators. They're using the JavaScript interpreter that's perhaps free within Mozilla, and then they're implementing features within the browser that aren't present because you're just dealing with a JavaScript interpreter. So you'll get errors like document.body is not found, window.location.search not found. And so attackers know this. They know that there's emulators running. This happens in the product, but this happens also in the tools. And so they take advantage of this. So there really wasn't tools out there that was very helpful for what I was looking for. So we need a tool like Fireshark, and I have specific needs, but once I developed the tool, released version 1.0, got lots and lots and lots of feedback, I realized that there was actually several other kind of needs out there. So as we'll see, it meets kind of the need for a researcher, pen testers, network administrators. Even if your site's not compromised and you just want to know about more information about it, monitor it daily, it's quite useful. Very visual if you'd like it to be. Pen tester actually looking at particular sites to gauge very quickly perhaps some reconnaissance information as to where the site is being redirected to. Looking at the website architecture, redirection chains, any of the JavaScript. So ultimately it gives you a very, if you'd like it to, with what the data can present, a very visual approach to reviewing the website. So imagine that you go to a website. If you've used Fiddler, Wireshark, Ethereal, generally what we're used to doing is dealing with things in a very singular manner. Connections, list views. So when you're processing this information, generally you're looking at each single line. It's been my experience that it's much easier to look at a picture like this, which is going to allow me to center in and take almost everything at once to figure out what's happening. This graphic or graph view basically allows me to place information on the nodes. I make them clickable, I make them accessible, as well as the edges. I can make, the edges can represent the connections, the response status, information about what that link really means and how it was created. So I can actually attach a lot more contextual information through a view like this as opposed to a list view. Both are useful, and actually Fireshark will allow you to create both, but it very easily allows you to create a graph view. So let's say, for example, youtube.com. You'd go to youtube.com, and very quickly, one of the things I can do is start color coding. You know, in my post-processing script, I can say, well, if it's an ad network, color it green. If there was a connection and it was an iframe connection, please let me know that. The connection was a 200 OK, that's great. Redirectors, status messages like 200. Quickly I can gauge this by looking at this particular view as opposed to a list view. It's quite helpful. One of the sites that was compromised through malvertising that I showed before, horoscope.com, it was really interesting because when I graphed this, to look at the content responsibility. And this is kind of a shift in a lot of the major websites out there, is that they're really not responsible for their own content. The green are advertising nodes. The blue in the middle is horoscope.com. And you can quickly see that when you go to horoscope.com, it's actually providing very little information on its own. And the ads, the tracking nodes, and the rest of the information that's being presented to the user is coming from other locations outside of the responsibility of horoscope.com. You can quickly gauge this, though. It's kind of nice. Same goes with not looking again at one particular site, but looking at several sites. This is the Alexa 25, and quickly I can graph it. I can look at the clusters of communities, Microsoft.com's community, MySpace.com communities, and I can actually look at what they have in common. So I've circled the communities, like Microsoft.com, and I've also circled the servers that they actually have in common, content that's actually served to, for example, Microsoft.com and MSN.com, or if there's any nodes that share commonality between completely different communities. And these nodes are generally tracking nodes or advertising nodes. So if I'm an attacker and I want to infiltrate an ad network, I want to see within the major networks which ads I might be able to serve to multiple different communities. This particular view is a graph of one mass injection. So imagine I'm quickly looking, I've got 20 sites, 20,000 sites, and I want to get a quick view to see, is there any common ground here? I can put it through Fireshark, it'll reproduce a graph like this, and I can see, are there any interconnections within any of the communities that I'm looking at? The blue represent the compromised websites, the red represent the exploit sites, and any interconnections are the redirectors, which is generally the case of what happens when you go to a compromised site. You put through a redirector, and then you land through the exploit site. It's not always the case, but it's generally the case. Another thing that Fireshark will reproduce is an ingress-egress report. That's the number of requests or responses that actually happen. So if I'm a malicious site, I want to look at how many requests are actually coming into these malicious sites. If they're not responding, I'm not going to see an egress report. I'm not going to see it actually responding back. But I want to look at both the ingress and egress reports. So I can actually gauge what are the most popular compromises, what are the most popular exploit sites, what are the most popular redirectors, who's responding, who's not responding. It might be that my IP address is blocked. It might be that that host was just taken down, but that compromised website is still compromised, and it's making a connection out, but the end host is just dead and not responding. But I also want to worry about content, or actually I don't want to worry about content. This is the obfuscation that we were looking at before. I don't really want to deal with 20,000 sites that has polymorphic obfuscation, and I have to interpret every single variation of it. I want to quickly get a generic insight into what it's doing. So from what we see here on the obfuscation to, hang on one second, to this particular view, we can see that it's actually deobfuscates that content, and this is the Phoenix exploit pack, and we can see what happens. Let me explain what happens. There's several kits in here, several exploits in here, from Java serialization exploit to some of the MDAC exploits, and quickly I can kind of do it by keywords, but Fireshark doesn't actually use any signatures. It does it through kind of a clustering mechanism, taking kind of snippets of hashes within it. So even if it changes, it can still determine it's the same pack. So that's what it'll do in this particular case. So how to use Fireshark? Really, really easy to use. This next version is even easier, but you install it like any Firefox plugin. You drag and drop it into your Firefox browser. It requires 3.0 and up. You create a data.txt file in your home directory. That data.txt file is going to have the URLs that you'd like to visit. You go to Tools, you go to Go, get your coffee, sit down, and forget about it. And it's going to visit each website, take all that information. It's got timeouts on it, so it's configurable, but it's set at 5 seconds to 15 seconds. And then it'll go to the next website, just so it's not stuck on any particular website. And what gets created is report log.yml. It's a YAML format, as opposed to using JSON or XML. And with that, that's the end of what Fireshark does. Fireshark has post-processing scripts that come with it. You can use these to create, GraphViz, the ingress-egress report. It's got some other Perl scripts that you can use. You can create your own, and that's kind of the purpose. I had a particular need, but someone out there has a completely different need. They can write a post-processing script to deal with that data, to view it, to not use GraphViz, to use a different graphing library, to do something completely different, put it in a database, correlate that data, which is what I generally do, but I haven't released the post-processing scripts for that, and that might happen. This is what the report log looks like. It's just in YAML format. It's the connections, any event that actually happens within the browser. Connections out, requests, responses. This is actually just showing the connections, but there's actually links to the DOM, the source code, that are dumped to disk, a random file name is created and it's referenced within the log file format. And again, it's all about the post-run analysis, the data correlation. After that's run, you can run the post-processing script, correlate it with ASNs, IP addresses, hosting providers. It's interesting for me to know where are the exploit kits. Are they hosted on bulletproof hosting providers, particular countries, particular ASNs? Because it's really about finding a bigger picture solution as opposed to just dealing with one single entity at a time. So this is uploaded. We're going to skip this, but this is basically just a video that actually shows how to install it. And again, it's really, really simple. Drag and drop, just like any Firefox plugin. Go to the Tools menu and hit Go after you create a URL file. So let's look at some of the use cases. So what we're going to do is we're going to analyze 3 exemplary injection campaigns. I chose these particular 3. We might hit 2, but we'll most likely hit all 3 of them because they happen every day. On any given day, week, month, there are hundreds of thousands of compromised websites. And in many cases, there's only a handful of actual similar attacks that are actually happening, and exploit sites, exploit servers that are responsible for this. So let's look at a breadth view analysis, and then we're going to actually gain a better understanding by diving and looking at it closer. And we're going to use Fireshark to do that. So injection campaign number 1. So here's a particular pattern, because in many cases, the first level is just to look for similar patterns, or to look for heuristics that say the page is just obfuscated. That gives me the most broad view, and then looking for similar patterns within that gives me something at least that I can cluster and kind of dive in and look even more closely. So this particular pattern within 24 hours was found amongst 13,000 websites. And what I'll do is I'll take about 500 of those sites. I just want to see, is it at all related? It looks related, but let's verify that. So we'll just take a subset, 500 out of 13,000. We'll take a breadth view. Let's hope that some popular campaigns emerge from it, that the injections are unique, and that either they're landing in the same host. The host could be by IP address, by ASN, by hosting provider. You can kind of go up and up in terms of levels of what you consider similar. And then we'll take a depth view. Let's look at the details of the attack, the screenshot, the source code, the DOM, the network traffic. And these are things that Fireshark will actually produce. So the bird's eye view. So I can look at this. I can kind of just, I'll produce it, go get my cup of coffee, sit down, kind of study it for a little bit. It's more entertaining sometimes to look at it from a visual perspective. It's only going to, I'm going to look at this for about 5 minutes, no more than that, just to see, are there any interconnections, redirectors, how many exploit sites are we actually talking about, where do we land? The red nodes, again, are the exploit sites. The blue in the middle are the compromised websites, and the green are generally advertising or tracking nodes. But more time I'll actually spend on the ingress-egress charts that are actually produced, because that's directly going to let me know, all right, well, what are the most popular hosts that are getting connections. So it was only 500, and I can see that this ClickSoar is actually getting about 28 connections to it. So it's interesting. Let's see, and what I'm hoping is that if I take a subset of 500 out of the 13,000 and I double that, or I triple that, it's going to grow linearly. So if I'm looking at 25 to 27, and I actually take a larger, a subset that's twice as large, I'm hoping that the number of connections, for example, to ClickSoar is going to double. And that's going to let me know that this particular site is really part of this campaign. So I'm going to look at 2 of these, I think, is the ClickSoar and this particular IP address, both of which show up at the top of this request chain. So let's look at that IP address, for example. What actually happened? So zooming in on the chart, for example, I can see out of the 500 connections to it. So I know I verified at least that this is still responsible. I can also see very quickly whether it's responding or not. There is a connection to it, and there was a response from it. And I can see that it wasn't an iframe or it wasn't a script that was actually connecting to it, because that's information that's added to the edge node, that perhaps it was just redirected through another means. So sure enough, so for example, Nerouge was one of the compromised websites, no longer compromised. And it went to, when you go to that particular site, you get redirected to a few different places. RasCop, Hinger, but if Hinger doesn't respond, you can see that it's making a green arrow to it, but there's no response. RasCop, on the other hand, you connect, and you get a 302 redirect to a particular IP address. So quickly you can gauge what's actually happening. And you can also see that for whatever reason, this particular IP address, which is malicious, is actually using Google to track how many users are actually coming to it. And it's also using some of the AJAX functionality. So here's a screenshot of what Fireshark will take. Again, we saw this at the beginning. It's a rogue antivirus. And you can quickly, which I've done, is create a report so that I can kind of go through all the sites and look on the right pane, all the screenshots. And it's more for manual analysis than anything automated, at least from the screenshot perspective. But it's very interesting, especially for a report or just to gain a good manual analysis view of what's actually happening. So I actually chose this particular attack because of Operation B49. Has anyone heard of Operation B49? So this was one of the largest. This actually happened on February 22nd. What it was one of the largest botnet takedowns, the Wolodak botnet, and several companies and groups were involved. Several security companies, several academic universities, several security groups, to take down the servers responsible, the CNCs, and any of the nodes responsible for sending spam. And it was quite successful at the time, at least, as it is with most kind of botnet takedown. It really helps for that particular moment in time. But Wolodak was one of the 10 largest spam botnets, and so this was a very big deal. Quite a lot of work. A lot of groups were responsible for this. What was interesting, though, from my perspective, is that the names of those hosting providers, the names of the servers responsible were released. And when it was released, RasCop was on the list. So from the perspective of looking at malicious websites, when you're spamming sites, it's interesting to make correlations between spamming groups, mass compromises, and how it's all working. Obviously, rogue antivirus was being installed on that machine, but it wasn't thought, at the time at least, that these redirectors were responsible for also spreading spam. And so this was interesting because new information was then provided that the RasCop and other Wolodak servers were not only sending billions of pieces of spam, but that they were responsible for acting as redirectors for malicious websites to rogue antivirus. Just one piece of the puzzle, but something that before wasn't apparent to everyone. So it was also interesting because I didn't really know that RasCop was even part of it, and when I was graphing this and running Fireshark again and again and again, all of a sudden when I'm looking at this one, RasCop and Hinger weren't responding. All of a sudden on February 22nd. So I actually thought Fireshark was broken, and I wasn't understanding if I was getting blocked, blacklisted, what was happening. And it was only a few weeks later that I got the list, and I was able to kind of go, aha, that's what happened. But this is a chart of basically those two hosts making, having connections being made to them, but not responding. And here's just a few of the nodes that I graphed that actually showed that. Even still, understand that this is the malicious webscape. Great, those redirectors, they're out of the picture. But that antivirus, rogue antivirus site, still live and well. Compromised websites, still compromised in terms of that iframe is still going to redirect the user, but to a redirector that no longer exists. So it's taking out the bridge but as we'll see, that quickly gets refreshed. So this is the ingress report looking at the connections. Again, it's just very quick view if I'm only going to graph a subset of information to see how popular this is in terms of the campaign. So another one on that list was ClickSoar. So this was coined the 8080 attack. It still actually is happening. So this particular injection attack had tens of thousands of injections, and I took a smaller subset of 5,000, and out of that I actually took 250. And one of the sites that was redirected was to homesalesplus.ru. So I looked at the ingress, which showed me I took 250 out of the 5,000. I looked at the code that Fireshark actually produced, and it was producing different variations. The only thing that was really strange that I saw was that they were actually adding a comment like code 1, LGPL, GPL. The only thing I could think of that I saw within these injections that they would do that, maybe to fool some really simple scanners that were saying, oh, there's some code, oh, for some reason it's licensed, we'll just skip it. I don't know. But they weren't doing anything via polymorphism. They were more just adding variations. But Fireshark, the cool thing is it was able to correlate, saying, yeah, this is the same attack at the end of the day, even though there's different variations of source code. Because it looked at the source, it looked at the DOM, and it saw that there was the same injection. This is just WinDiff loading up the source and the DOM view, which is the final content after JavaScript is run, to show what has been added after JavaScript. So this is the injection attack. A lot of code, complicated in terms of there's nothing you can make out of this that makes any sense. And then here's the DOM view, the mutable memory representation, basically, of the HTML after the JavaScript and the events that actually run on the page, and the load event has been called. So it's just a script that's running to homesales.ru.8080 with a particular pattern. So further analysis showed variations. Home sales wasn't the only one that was used. View home sales. The one particular thing that was consistent amongst all of the compromises was that it was .ru and 8080. But the content was the same. It led to the same pages. And the report that I was able to create through Fireshark allowed me to see this. Similarities, again, 8080, RU domains. Legitimate content actually was on port 80. The malicious domains were mapped to 5 different IP addresses. So this was part of the post-processing scripts that I actually ran afterwards. So I had the domains, and then I was actually able to see if there was how many IP addresses were associated with those domains. It's information that perhaps you can get from Cymru, which is a great organization that gives out domain information, IP information in terms of malicious host, malware. But I was able to quickly see what associations were made with that different host. And I could also see the hosting providers. LeaseWeb and OVH, LeaseWeb in the Netherlands and OVH in France were consistently, even though all the hosts were different, consistently being used as the hosting providers. So, never-ending story. As we saw in the last one, even though those redirectors were taken out of the picture, this particular attack ended again because we found out sometimes we'll work with the stop badware guys, and sometimes, a lot of times they're responsible for doing takedowns. That's what they did with this particular attack. But within days, everything was refreshed. Sites were brought up again. So it's important to realize that attackers are constantly monitoring not only the compromised websites, the redirectors, and the exploit pages, and all the activity that's happening, and constantly refreshing everything. They have an endless amount of domains that they can register, machines that they have control of. As soon as something's brought down, within days generally it's brought back up. It's just always going to be a cat and mouse game. That's the reality of things. So observations from this particular attack that Fireshark was able to show me was that the compromised websites were updated automatically. The as we saw before, that the websites was injected with multiple redirectors, and this was actually found out through manual analysis. But it's my belief that the majority of these sites were compromised via stolen FTP credentials, and that's because the same sites I was actually able to correlate the data with Gumblar. That's the mass injection that had over 60,000 websites that were actually compromised, and they were the same. And we knew through investigation that all the Gumblar sites, it was because of stolen FTP credentials. So it's an easy kind of correlation to make. So injection example number 3. This particular website that I'm showing right here, again, had about 5,000 infected pages. It looked about, that's pages, it had about 5,300 unique hosts. It's very common when a site's compromised that they're not just going to compromise the main page. They're going to compromise any of the majority of index.html, index.php, whatever it might be, some of the main pages in there. So that's why you'll actually get less unique hosts and more infected pages. So I sent in about 1,000 for analysis out of the 5,300. And then I was able to look at the egress report. That's the responses. So in this particular case, what I was interested in using Fireshark for was, don't tell me how many connections are being made out, but tell me who's actually alive. I actually wanted to know the redirectors that were actually responding. And so I was able to see that, for example, Sport Gun was a very common attack. That's why I chose this one. But it sent back 50 responses out of that particular subset. But it's very common, again, that if I'm scanning from a particular IP range, and I switch my IP range every single day, I come from virtual hosts all over the world, but if I'm doing it for within an hour, within a few hours, I'm going to get blacklisted. And I graphed it, sat down, take a look, and I could see all these compromised websites going to the middle of the screen, which is to the redirector, and it making a connection to the bottom of the screen, but the bottom screen's not responding back. And that could be because it's not alive, but I assumed it was actually because I was blacklisted. So I went, switched my IP address, and sure enough, well, this is actually it, not responding. I actually, one of the reasons I chose this website is because I actually thought that, at least out of the crowd that I'm with, there's many times when you're on a machine and you're like, oh, I could check real quickly, but I'm on the web, what's my IP address? And one of the first websites that'll actually pop up is howtofindmyip.com. This site was compromised for quite a while. And it was a site that almost everybody I knew was going to when they were on the web, and they're like, quick, before I'll just check my network config. Instead of checking their network config, they would just check on the web, and that's how they would find out their IP address. Site was compromised. Again, it was not, the exploit site was not responding, but the redirector was. Switched my IP address, and sure enough, it was responding back to me. So when you're fooling around with a lot of malicious websites, just keep in mind that's pretty common practice. You want to have hundreds of virtual hosts at your disposal to just switch around your IP ranges. It's typical that they'll more block a single IP address rather than an entire block of IP addresses. But it's good to alternate between IP addresses. So success, I was able to kind of fit all the pieces together. The redirector, the compromised websites, the exploit site. I can see that there's a 302 that the Sport Gun is actually sending back, and it's sending me to up level. And then I'm able to see the connections. What's actually happening when I go there? Very quickly, I recognize this pattern, but this is an exploit kit, and it's the JavaScript is run. I'm not showing the JavaScript actions here, but I'm showing the connections, and it's trying to fetch some jar files, class files, PDF files, some exploits. And it's kind of the default slide. Not that VirusTotal says it all, because it is majority of it is static analysis, but hardly any of these were caught. And that's the case with most of the exploits, most of the polymorphic malware that's served by these exploit kits. This had a 21% detection rate amongst the majority of the 41 vendors that are on VirusTotal. You'll find that these attackers who are actually selling these exploit kits, they're not using virus total, but they have their own systems. They're checking constantly how successful is their polymorphic code, the exploits that they're using. Regardless if there's a patch out, you know, it's going to happen. It's going to be successful on quite a number of at least home users and corporations who haven't patched Flash or Adobe Acrobat. So looking at the at up level, which was the end result site, the end exploit site, Fireshark was able to grab the main page, and then it allowed me to see one of the headers, and I quickly recognized that was just the LNR exploit pack. But the clustering, the cluster within Fireshark was also to tell me that it was the LNR exploit pack, and so I could now put this in a similar attack bucket. I was able to look at the obfuscation, which is the main source code on how to find my IP.com, and I was able to deobfuscate it to just realize that that entire block of obfuscation, once deobfuscated, all it came down to was an iframe that redirected me, which I knew before, but it's just interesting to be able to take both the source and the DOM and have that information within seconds and not worry about any other tools that are out there. So I can also have the DOM for the exploit kit, and I can store that in a database, which is what happens from my perspective. I can look at the various exploits that are involved, and Fireshark will actually save to disk, not only in a temporary folder, but it will actually save it to another folder, all the exploits that are downloaded, all the jar files for further analysis. So some of the observations from this last attack. Bad guys, as we know, they're tracking, they're hiding, they're blacklisting, they're using redundant redirectors. You're not always going to go to the same redirector. The majority of the cases, actually, that redirector, though, is going to belong to the same hosting provider, even though it's a different host. The exploits that are being used are current, constantly updated. You know, Adobe is constantly being found to have more vulnerabilities, even though that they're putting some pretty great security measures in place. Any third-party add-ons are going to be used within some of these exploit kits. I only showed some of the major ones, but there's quite a lot out there that are using exploits that aren't always just for Windows. Not as typical, but it does happen. But they're current exploits. It's not just about 2000 to 05. It's 2010. A lot of the exploits that are out there for IE, for the browser plugins. The exploit kits, they're easily attainable, not for me as a researcher, but for the attackers. They're in these same groups, and they are able to share and buy via being part of these groups. As a researcher, it's actually difficult to enter into the underground and buy them, and this actually helps because I could actually, once I am able to identify a lot of these exploit sites, I can work with the providers and many times actually get the kits that are up and running on those sites. So many of the kits are polymorphic and exploit malware, and thus one of the big things that you should know is that when you go and you test a lot of these sites in VirusTotal or another particular site, if it's only static signatures that are being used, they're always going to be behind. It's not always the case. Heuristics are involved, but if it's static signatures that are simply being relied on, it's not going to be enough. So the releases. So again, it was released at Black Hat Europe this year. When I released it, it had about 10,000 downloads. I had an overwhelming amount of feedback, to which then I worked on, and am going to be releasing the next version the end of this month, most likely next month, because I'm doing a little bit of beta testing. But Fireshark 1.0, it's a browser plugin. It's got some Perl post-processing scripts, output something in YAML format. Some of those post-processing scripts rely on the Cymru ASN database. Uses GraphViz. Pretty easy to use, but does expect that you're going to run it either on a Windows machine or a Linux machine, anything that runs Firefox 3.0, and that you're probably going to run those post-processing scripts on a Linux machine to actually run your data. Fireshark 1.0, which is going to be released, I think in November, it's way easier to use. it's actually much more the intention is actually from a distributed standpoint, a network perspective. You can actually use scripts to put this into a VMware cluster and run multiple instances of this. Configurable options. There are some in 1.0, but there's a lot more in the 1.1 version. User agents, where you want to save the files, the proxies you might want to use. And then I switched it to using JSON instead of YAML. And the post-processing scripts are going to be in Python instead of Perl. It's just, it was more the crowd that was giving me feedback. That was one of the large things that they requested. So, and it was actually a lot easier to do. So, where to download it? Fireshark.org. It's up and running. You can go there. It's all in Google code, but it's also linked from this particular website. It's free. It's GPL'd, open source. Right now it's just the Perl scripts. There's no Python scripts up there. Included for the post-processing once it's run. So please use it. So just to take away, from a researcher perspective, compromised websites, they're only increasing. Every single day I have to deal with hundreds of thousands of sites. Links are constantly updated. The current tools I didn't find to be sufficient, and maybe in-house tools, but that's obviously not public. So I wanted to provide something that was public, open source to use. I'm really not intending. I'd love contributions to the source code, but I'm going to continue it as a solo project. It's going to be updated, frequently. I'm always looking for feedback. So you can use Fireshark to test your own website. If you're a researcher, test it for tens of thousands of websites, your own, and it brings all the pieces together. So that's about all I have. Is there any questions?
There's only time for one question.
All right.
So.
One question. All right. If there's no questions, then catch me afterwards, and we'll talk. Thank you.
Some small announcements. For the people that saw the Finding Malicious Code talk from Matthias Madou, you can actually see their tool. There's a live demonstration in the room upstairs in Calypso for the next hour for those people that are interested. I have also the pleasure to announce that there is an extra lockpicking workshop after the next break at 5 o'clock in Orval, for those that are interested.